Hello, Freeport High School students. Mr. Kovac here again. I want to do one more BCA table with you right now. And this one goes to level 3, I call it, because there is this thing called limiting reactants. This is really practical, but not fun to deal with on the first day. So we'll ease into it. So limiting reactants and excess reactants are talk about if you have two chemicals you're mixing together, you might not mix the perfect amounts. You might have too much of one or too little of another. I'm trying to think of an example. Sometimes if you're trying to make partners for a dance and your school has 600 boys but has 700 girls, well, if you're trying to match one guy with one girl for the dance, you're going to run out of one before the other, right? One sex, one gender. So we have this little issue that we had to deal with, and the BCA tables can help, but it's level 3 for a reason. It's a little bit tough. So stick with me. Let's see if we can figure out this by studying problem number 8. So how many moles of water can be made by reacting 10 moles of hydrogen gas with 8 moles of oxygen gas? They also ask us which gas will be left over and how many moles are left over. This last question is why I love BCA tables, because we could do one BCA table and answer 1, 2, 3 questions all at the same time. Okay. Before we go on, we should balance this famous equation, and you've seen this one before. We'll need 2 hydrogens for every 1 oxygen to make 2 waters. So remember, the B is the moles of uh, the moles before the reaction, and it looks like we're given 10 moles of hydrogen gas, and we're given 8 moles of oxygen gas. So we're going to put 10 moles here, and we're going to put 8 moles here. And I'm also going to throw in a little 0 here because we don't have any water to start with. So one of the questions asks us which will be left over and how many moles will be left unreacted. So we're going to be studying down here. I don't know yet if hydrogen's going to be left over or oxygen's going to be left over, but I know I'm going to use one of these numbers here. I've been using marker for this, but it is important now I change to a pencil because I might have to erase the answers here. So if I use 10 moles of hydrogen and 8 moles of oxygen, one of these are going to run out first. Well, which one runs out? There's all kinds of techniques where you can avoid guessing and checking, but I just like to guess. I just like to guess which one's going to run out first. And so if I think that I got to put a 0 here or a 0 here, I'm going to do the wrong way first to show you how you know if you're wrong. If I put a 0 here, I know that this change will be -8, because if I start with 8 and I use all of it, I have 0 left over. So now, because this number is twice as big as this number's got to be twice as big as this number, and I would get -16, because 16 is twice as big as 8. I need a 2-to-1 ratio. And if wait a second, if I start with 10 moles of hydrogen and use 16, I'm going to end up with -6. Remember, the B plus the C always equals the A. You cannot end up with less moles than 0. It doesn't make sense. So in my 50-50 guessing whether 8 moles of oxygen would run out first or 10 moles of hydrogen would run out first, I happen to guess the wrong one. So I'm actually going to erase all my pencil work and start over. Instead of putting a 0 here, guessing that maybe oxygen ran out, I'm going to go with confidence with my green marker, because I know the answer now, that this is going to run out first. We're with 0 moles of hydrogen. So I'm just guessing that I'm going to run out, and hopefully this number will not be negative when we're done. So if I'm going to use up all the hydrogen, I will use all 10 moles. Again, I'm putting a -10 because I'm using all 10 moles. This change is going to be -5 because a 2-to-1 ratio, a 10 and a 5. 10 is twice as big as 5. So my hydrogen change has to be twice as big as my oxygen change because of the balanced equation. And if I have 8 and I use 5, 8 plus -5 is 3. This is our excess. This means that if I were to mix 10 moles of hydrogen and 8 moles of oxygen, like the question said, I'll use up all the hydrogen. I'll be left with 3 moles of oxygen that were extra, unreacted. We call it the excess reagent. So if I asked you which gas would be left unreacted, you would say oxygen gas. How many moles are left over? I would say 3 moles are left over. Again, maybe there's even more questions down the road for level 4 problems where they ask for grams instead of moles. Or maybe they ask in addition, how much water would you make? And then you'd have to put a positive 10 here, and you'd get a 10 moles of water. That would be telling you how many moles you make. Let me write that down just for fun. If I put a positive 10 here, because again, a 2 to 2 ratio, these numbers are the same. I have 10 moles here. What does this mean? This is how much water we would make. This is how much is left over. The reason we're saying excess left over or made is because I've crossed from the reactant side to the product side. Okay, hope these help you learn.